Yeah, Martha.
It appears that the information you gave on the specification for the pipeline is generally talked about the manufacturing of the pipeline. I'm curious, the existing pipeline that's been in the ground 40, 50 years, I understand, you know, I know of nothing much that's manufactured the same way today as it was 40, 50 years ago. So can you describe the differences in the construction of the in-ground existing pipeline compared to what is there today? What the new pipeline will be? How are they manufactured differently?
I'll let you take the first shot at it.
Okay.
I mean, the pipe, I mean, what we have in the ground, and then I'll let him, because he's much, pipe that is in the ground is 26-inch pipe with varying wall thicknesses. Kind of along the same lines as what we just laid out, is based on where it's going. Over time, we've added wall thickness in populated areas to be able to maintain pressure. As I said earlier, I mean, so that was built, it's a, you know, it's a steel pipe that has a center weld on it, so think of a flat piece of steel that's formed and a weld across the top. That's what most of that pipe is. You know, that is the same type of pipe that is used for most of the interstate natural gas grid that was laid post-World War II in the 50s and early 60s. We know what the components are of the steel. We know what the makeup is. We know what the chemistry is from the reports that we had associated with that. So when we're running the analysis to understand and be able to determine what the maximum pressure we can operate in, all the same factors you've heard here go into that calculation. You know, it was built pursuant to API specifications that were in place at the time. So you have the same rigor that was done with 1950s technology, 1960s technology versus today's technology. But
So do we know that that existing pipe meets the same construction criteria as the new pipe that will be installed? In other words, does the new pipe have that same seam, and will they have the same thicknesses? How do they compare? What's the same and what's different?
The seam is different between the new pipe and the existing pipe. The wall thickness is different, but we're operating the new pipe versus the existing pipe at this existing pipe at lower pressure, still within the DOT and PHMSA regulations. We still have the same design factor. The API 5L spec that the existing pipe was manufactured to would have had similar requirements that current standard has, although it's through different additions. We've cut out pieces of the pipe, of the existing pipe, hired recognized metallurgists in the industry to analyze that pipe more ways than I understand, so we can understand the composition of the pipe, the yield strength of the pipe, the impact toughness of the pipe, so that we can assure ourselves when that pipe is put into operation, it's fit for service, for NGL service. Does that help answer your question?
Partially, I suppose. One other question is, you gave wall thicknesses for different types of conditions that the pipe would cross, but nowhere on the list was there karst geology listed there. And considering the fact that, so as you're running a pipeline through areas that may change over time and may have voids created, which of these wall thicknesses would run through those areas?
So, right now, the line pipe, the table that's identified as line pipe, would run through the karst areas, but the karst study is still, underway. So our mitigation efforts that we'll employ in the karst areas have yet to be fully determined because the study isn't complete. But at our disposal is, you know, enhanced leak detection, heavier wall pipe, installation methods. There's numerous methods we can employ to mitigate areas where karst is found.
So to ask the question slightly different, is it safe to say that, you know, there may be instances, be it karst or be it some other sensitive area where we may use that half-inch wall
right now, there is at our disposal to increase the wall thickness through punch thickness.
So would you be informing a landowner of what conditions and what kind of pipe you're installing on their land? Or how will they know if they know they have those conditions on their property, what thickness pipe they'll be installing and what precautions and measures you're taking?
I'll defer to Rob. I don't know if we.
When the project is complete and every landowner gets an as-built plat map for their parcel that describes not only the location of the pipe along their property, but it also identifies the specifics as far as wall thickness, linear distance, location of the pipeline within the easement, et cetera. So as far as line pipe thickness or wall thickness of the pipeline, that would be included on the as-built parcel or tract map plat that they would get at the completion of construction.
All right, I'm sorry.
Sorry, part of the question on, there were some concerns with respect to the existing pipeline, again, repurposed line. Perhaps the gentleman in the back was making a statement about its testing that would address this, but there was concern stating that it was an obsolete exterior protective coating that are known to disband, and that reduces the effectiveness against corrosion. Do you have a direct response to that point?
Well, I think that there's two responses. One is, as I stated earlier, we either completed or in the process of completing what is known as a close interval survey, which means that we're going to walk the pipeline and basically take cathodic protection readings every 3 to 5 feet. We basically, they use it, will like a walking stick to take these readings. So that gives us a very good sense of what the cathodic protection is on the pipeline. That's in addition to having already run the tools, where we have a sense of whether there's any external corrosion or internal corrosion. Plus, we've been operating that pipeline, this was since 1952, 54 timeframe. We've done a lot of digs in the pipeline. This is a matter of routine. We have a pretty good sense of what the coating is and what the shape of the pipe is. Well, by finishing the close interval survey, that will give us even a better sense of what the quality of the cathodic protection is, and basically the ability to use cathodic protection to protect the pipeline from external corrosion.
I could add to that as well. You're talking about the past, and Mike expressed very well that Boardwalk has done an excellent job of maintaining those pipes that are going to be converted, and in the future, Williams, as the operator, will continue to maintain these pipes to check cathodic protection, to periodically do close interval surveys on the pipeline, and also periodically run internal inspection tools on the pipeline to double check to see that we are doing a good job. And if we do find any defects that are as a result of corrosion, we will go out and repair those defects, and then we would also repair the coating system and the cathodic protection system to make sure that we don't have recurring defects.
One last question I have with respect to the repurposed pipe is your pressure test that you will conduct with that pipe before putting it into active service. Will that be taken up to pressures which could account for levels that might be experienced in short-term spikes, operational variabilities?
The hydro test that we will do on the pipeline will be dictated by FEMS's regulations. And I may say this wrong, so jump in here.
Yeah,
We'll take it up to 125% of its operating pressure, maximum operating pressure. And are we going to do a spike test?
Right, we
Right out.
will be testing at a minimum pressure of 125% of the maximum allowable operating pressure. And when you talk about spikes, the regulations do not allow us to ever have any spikes that would exceed 110% of the maximum allowable operating pressure.
As part of the engineering effort, we do what's called a transient study to determine spiking pressures, and we mitigate that.
Go ahead.
Ready to move on? Pipeline. I didn't expect as many steel engineering questions.
You hit his sweet spot.
Yeah, that was the,
Yeah, well, they're very good, and that's a further example of, you know, I didn't put it this way earlier, but we brought the A-team to address all these issues, and I hope that's evident here. Let's talk about, Leander's gonna talk about the construction process itself, and what's gonna happen, and what people can expect to see in installing the pipeline. Go ahead, Larry.
Pipeline construction is pretty unique in that really it looks like a moving assembly line once you see it in the field. A large project such as this one is typically broken into manageable construction lengths called spreads. We've heard that term tonight. Here in Kentucky, we'll likely have about 3 spreads, and so that's 3 separate work areas, which will be constructed by contractors and their teams. And these spreads consist of a team of highly specialized and qualified work groups. Each spread is composed of various crews, and we'll kind of walk you through those, each with their own specific tasks and responsibilities. As one crew completes its work, the next crew moves into position to complete its piece of the construction process, which is kind of like an assembly line. Now, prior to construction commencement, however, Bluegrass will staff a construction management team that will provide third-party craft inspection of each of the tasks I'm about to describe. No work on the pipeline can take place without inspection. One of the first things that take place is a pre-construction survey. Before construction begins, crews survey the environmental features along the proposed pipeline segments, wetlands, water bodies, features like utility lines, drainage ditches, etc. Those are located and marked to prevent any accidental damage during pipeline construction. Next, the pipeline center line, where the pipeline is going to lay in the ditch, in the right of way, and the exterior right or left of the right of way. Those boundaries are surveyed and staked. This becomes the workspace. This is the work area between those stakes. Now, this first slide up there, you can't maybe make it out too good, but that's the first step after survey is clearing. Clearing will have some grubbing of stumps, but clearing and grading is that first step. And clearing essentially means clearing the right-of-way of vegetation. And at that point, once clearing starts, then temporary erosion control measures are installed to prevent any erosion as applicable to that activity. Once that's taken place, the next step is trenching or ditching. You can see an example of that over there on the right. And the way we work this, it's kind of done in a series of steps. That particular picture doesn't show topsoil segregation. In agricultural lands, we will segregate topsoil from the subsoil underneath it. And it will be stockpiled separately. And the reason we do that is because when we put things back together, when we backfill the trench after we've installed the pipe, we put the subsoil back on the bottom around the pipe, and then the topsoil, as best as possible, goes on top of the subsoil. This is achieved by using a trench machine like you see up there in the picture, or backhoes or track hose excavate the trench. The next step that you see there on the bottom is what we call stringing. That truck there on the bottom of the slide is what we call a stringing truck. Essentially, individual joints of pipe are strung, if you will, along the right-of-way adjacent to the excavated ditch. And they're arranged so they're accessible to the personnel that's going to be putting it together. Also, during the stringing, the next step in the construction phase is bending, what we call bending. Obviously, most of the pipeline route is not level, and we don't go in a straight line. So we have to bend the pipe a little bit in some places, and so there's a pipe bending machine that bends these individual joints of pipe to the desired angles at locations where there are significant changes in the natural ground contours or where the pipeline route changes in direction. And something if you'll go to the next slide, Keith, something I want to point out as an example, that top right-hand picture. Now that's pipe that's already been strung. It's been bent and welded together, and looks like it's been recoated. It's getting ready to be laid back in. I don't know if you can see from that picture, but you can see the pipe bending a little bit. It's just kind of an example of how flexible steel can be. I know that kind of sounds a little bit odd, but it really, the pipeline is flexible. We've talked about that a little bit in earlier discussions, but it's really important to the design of the pipeline, so it can not only manage the topography, but so it can manage some outside external forces like we've talked about. After the pipe is strung and then bent, then it's welded together. Once it's welded together, it's placed on temporary supports right along the trench, and then all welds, 100% of the welds, are visually inspected and x-rayed. If any welds are found to be deficient, they're repaired right there on the spot. As already been discussed by Blaine and others about the coating, most of our pipe will be mill coated, and then prior to putting it back in the ground after it's welded, we have to also coat those welds. And so prior to the final inspection, the entire pipeline coating is electronically inspected to locate and repair any coating faults or voids. We've already talked about that's jeeping, as we've already discussed. So here they are lowering the pipe back in, and it's assembled, lowered back in the trench by those side boom tractors. And then the trench is backfilled. That's the bottom slide down there. The trench is backfilled by using backfilling of bladed equipment, and no foreign materials are permitted into the trench. After the pipe's backfilled, then the pipeline will be hydrostatically tested. Again, in accordance with our spec and in accordance with DOT regulations, to 125% of operating pressure. We test the pipe with water. Once that water has been utilized, the test is over with. It'll be disposed of in accordance with state and local regulations. And additionally, post the hydrostatic test, we'll run an internal inspection tool that will inspect the pipe for opality, where it's not completely round, and we find some exceptions there, or dense, and if any discrepancy of structural integrity is discovered, then that non-conforming pipe is located, that piece of pipe is located, excavated, cut out, and replaced. After that's done, then restoration of the right-of-way starts in earnest. And our policy is to start cleanup and restoration of that right-of-way as soon as possible. One of the main reasons is we want to stabilize that disturbed soil, and so it's really important that we try and recontour that right-of-way that we disturbed back to original topography. as close as we can. So at that point, you see some pictures up here of post-construction right-of-ways. Now, that's not immediately after we're done with pipeline. But as best as possible, we're required to monitor. A lot of it will be part of our permit requirements to stabilize that right-of-way prior to us vacating the project. So, and that doesn't happen immediately. It's usually 1 to 2 seasons before that right-of-way is stabilized.
So, Lee, if I may interject,
Sure.
you see up here that there's some crops. You know, during the construction phase, we'll compensate the landowner if they miss a growing season. So we'll adequately compensate them for that as well, so they're not out of pocket for missing that particular growing season.
Why don't you talk a little bit about the land use in restoration to habitat, so the landowners want a specific land use?
Yeah, we work with every landowner individually and negotiate and talk through what they would desire to see that land restored back to. In some instances, we work with some other third parties to create habitat for wildlife. There may be some possibility, we have on a lot of other projects where the agency may request that we establish specific habitat for certain species. We don't know that yet on this project because we hadn't worked through all that just yet. But certainly in agricultural lands, another big concern, especially as you move up towards Ohio, we see a lot of drain tiles in cultivated land. And to the best of our ability, we're going to try and identify those drain tiles prior to construction, try to route our pipe on those parcels so that we can either avoid or get in between them, but we're accountable to the landowner to mitigate destruction of those land tiles as best possible during construction. And certainly, we put things back together and make sure it's working post-construction. Not guarantee those farmers make sure they're working post-construction. So, any questions?
Could you describe the bed that you lay this pipe in? Does it go right on top of the bedrock? Do you put something down? And the other question I've got along those lines is, earlier somebody mentioned the pinnacle bedrock that you could come in contact with. What and how do you protect your pipe in those areas?
That's a great question. It looks like, and we don't have the definitive analysis yet performed, but it looks like we're going to be encountering some rock on this pipeline route. And certainly, past excavating the rock and creating a trench, where we had that, we would bed the pipe. And so even to the extent where we may have to bring in farm material to bed that pipe, because we're going to make sure, but the integrity guys get after us when we put rock on a pipe on rock. It just doesn't work.
It doesn't work.
And so because it challenges our coding and as well as cathodic protection efforts. So yes, the pipe would be bedded. And what was your other question?
How do you deal with those pinnacle?
Well, there's a few techniques, but certainly where we would have to be concerned through those karst areas of any voids, there's a couple of ways you can do it. There's actually, we would do some geotechnical work from the standpoint of putting in some supports, basically footings to tie some things together. We've even bridged. You would have a separate physical structure to carry over those areas, and would help strengthen and support the pipe, just in case of some type of change in shape of that pipe trench.
I think, and maybe Mr. Waters can mention it, but with the geophysics testing, I mean, we would be avoiding pinnacles.
We'll be identifying them, and then one of the
Yes, ma'am. Be both of those. I would say, you know, if we can excavate with a hoe, we're gonna do that. There'll be some that's some of the rock that's softer than others. But certainly where the excavator won't work, you know, it doesn't look like the rock's gonna be that applicable to more like a rock saw or something like that. So we would be doing some very shallow blasting, and we will have a completely separate, you know, specific plan to blasting. It would again coincide with the state. I can't recall what agency that manages those requirements, but we would be doing that in accordance with that agency on blasting, any kind of blasting. But there will be multiple methods of trying to get through the rock. Yes, ma'am.
If I may, it is 8:35. Could I ask for everyone's patience for about a 5-minute break? I don't know about you guys, but I'd like to stand up for a minute and stretch my legs. And let's try to regroup at 20 till. All right, and that'll give everybody a chance, and commissioners, I'd like to, if we could come over here for a minute, I'd like to have just a brief discussion, and let's regroup in about 5.
We're almost done.
Okay, yeah, I thought so. I thought it'd be a good time to maybe everybody kind of tie a few things together. Thank you all very much. Again, I appreciate everyone's time. I appreciate the break. I know my legs do. It looks like right now, based upon the track we're running, it looks like probably going to be, by the time, I'm not for sure how much longer it's going to take on the presentations. Just looking at time, you'll probably look around, I'd say around 9:30.
We could be up by 9 probably.
Well, I don't want to rush anybody. I'm just saying, you know, for everyone's own information, we've had a couple of people say, look, I live kind of far away and I'm going to try to get home. And I want to say before I forget, again, I appreciate everyone, public especially, their time. And I mean that sincerely. I appreciate our guests coming in tonight. It has been very informative thus far, and I look forward to hearing the rest of the presentation. So with that, I don't want to take any more time. All right, so please.
We got a question, and sometimes when you're in the industry, you don't realize that you're using terms that may confuse others. But one of the things we want to make very clear is, well, this pipeline is a natural gas liquids pipeline. It is governed by the same regulations that govern oil pipelines or refined product pipelines. So once in a while, we will slip and we will talk about oil pipelines. Because in our minds, the regulatory scheme from the Department of Transportation are the same for oil pipelines as they are for natural gas
For
liquids.
the oil.
So, yeah, so to the extent we've caused any confusion tonight, I apologize for that. That's just one of those things.
Well, I appreciate that. I think it's what happens in this business is when you get into all these different, the acronym war, I call it, you know, it's easy to get confused, but I appreciate that clarification.
Well, Mr. Chairman, I think we can be out of here shortly after 9, depending on the questions, but next up is Ron Whitaker. He's in charge of safety and emergency response, and can talk about the operations of the pipeline. It addresses some of the questions that were asked earlier. How the heck do you guys do this once it's in service, and some of the safety issues? So I'll turn it over to Ron Whitaker.
Thanks, Bill. When you talk about operations and safety from a Williams perspective, you can't talk about it without mentioning our system integrity plan. It's what we use to control physical risk to people, our employees, the public, to the environment, and to assets. It varies from things around training, human protection, contractor management, environmental stewardship, pipeline integrity, management of change, and incident management. All of those things are a part of that. You really can't talk about these two things without mentioning that. When you look at the operations of Bluegrass, it's going to be a combination of field employees who are on the ground and a pipeline control center, which we've already talked about a little bit earlier, that's in Tulsa, Oklahoma, that is manned
ran 24 hours a day, 7 days a week, 365 days a year. When you look at the people who are in charge of those pipeline systems that we own and operate, as far as average tenure, it's almost 18 years per controller. Part of the things they do in addition to actually controlling and monitoring pipeline conditions would also be an integral part of the leak detection system that we have. When you look around safely operating a system like that, obviously we have to have highly trained and qualified employees. And like we've mentioned again and again, PHMSA, which is the Pipeline Hazardous Material Safety Administration, I know we've thrown that acronym out multiple times, or DOT. And when we look at the liquids pipeline system, it's specifically DOT Part 195. But there are requirements, DOT requirements, around training and qualification of people who perform tasks on this system. There's a PHMSA rule called the Operator Qualification Rule, that in order for either our field employees or our controllers or even contractors to perform specific tasks on that pipeline system, they have to be trained and qualified. We have to track that qualification, and there's a requalification process that goes along with it. Typically either a year, 3 years, or 5 years, depending upon the frequency and complexity of that task. In addition to that, DOT PHMSA also has a rule specifically around control room management. That's been implemented within the last couple of years. Talks again about controller training. We have a simulator that we use in our controller training program where we put them through simulated release scenarios, track how they react to it, and from a lessons learned perspective, we review that with them. In addition to that, to the extent that you understand that this is 24 hours a day, a big part of that is the fatigue management program. We talk with our employees about proper diet, getting the right amount of sleep, the amount of hours that they can work on a weekly basis, and even to the extent that we have to make sure that they have the opportunity to get 8 hours of sleep every day, even where they might live. So it really is about having a highly trained and qualified workforce in order to operate a pipeline system like this. That's another, it's hard to see with the lights, but that's another view of the Pipeline Control Center that, again, is in Tulsa, Oklahoma. References again back to PHMSA or DOT. And there are references that we've made already to regulatory requirements and who oversees the construction of a system like this. As far as the operation, it will be federal DOT. OSHA is certainly a regulatory requirement or requirements that we have with our own employees. EPA again, but talking specifically for DOT requirements around leak detection. Within 195, there are those requirements that we've got to have a means to detect leaks on our pipeline system. We've got to be able to track the capability of that system. Leak detection and analysis would include the sudden impact of failures as well as smaller leaks. And the operator has to consider those things as part of their leak detection system. What is leak detection? The best part of leak detection is leak prevention. We as an operator want to be much better at protecting the integrity of the system, keeping the product in the pipe, than we are at responding to a release. But part of the leak prevention program would be our right-of-way inspections that we're required to do by DOT 26 times a year, not to exceed 2.5 weeks. We do that typically with aerial patrol. Depending upon the situation, if we have an abnormal operating condition that's identified by pipeline control, we can certainly have people on the ground to do investigations on that. We've already talked about these, what we call smart pigs, these inspection tools that we run through the pipe, typically on a 5-year interval, depending upon the operations. Looks for external anomalies, internal corrosion, weld, so forth and so on. So that is an ongoing system integrity process. When you look at our computational leak detection system, there are really 4 components to that leak detection system. And each pipeline system is unique. Number 1, you have to understand the throughput of that system. Number 2, you need to know the composition of that product. Number 3, third component would be instrumentation that gives you pressures and temperatures, as well as meters, metering the product in and out of the pipeline system. And the 4th component, and it's a very important part of it, is the experience of the pipeline controller that's actually controlling our system. So all of those put together, that's the computational leak detection system that we use. Emergency response planning, and I want to emphasize the word planning on this. And I just talked to a young man here that was interested in, he has a friend that's, I believe, is the regional manager in this county for emergency management. The first thing that we do in regards to the emergency response is planning. We go in, we develop relationships with the local emergency response agencies, the LEPCs, the regional emergency management directors. We train with those agencies annually. We will have a county-specific emergency response plan. As a part of that plan, we will train with the local emergency response agencies. We have employees who are trained in HAZWOPER, which is Hazardous Waste Operations and Emergency Response. So we will do that. We are required to do at least 1 drill a year with emergency response agencies, not in every county or every region, but at least 1 along the system. Every 3 years, we have to do what is called a full-scale drill, in that we work with the local emergency response agencies, we come up with a scenario, we call our employees out, actually roll apparatus from the local emergency response agencies, and respond as if it were a real release. As we go through that, and on the back end of that, just like we would with a real release, we critique our response, talk about what everyone did well and what we can improve on to make it better next time. To kind of work through the process, the first 4 or 5 sections of our emergency response plan. The first thing is that we have to recognize that an event has taken place. Once, whether that's recognized by pipeline control, by a member of the public, or by one of our employees, the next step that we go through is notification. We notify local emergency response agencies. The next step in that would be to notify our local employees. The next step in our emergency response plan is pressure reduction. What we're going to do, if we have a release, and we've already talked about our mainline block valves and the fact that some of them are motor operated valves, they're automatic, they can be closed from Tulsa. The pipeline controller would close the closest valve upstream of the release. Downstream of the release, they would run all of those units, those pumps, until they went down on low suction, which would pull as much product away from that location as possible, and then go back and close the closest motor-operated valve downstream. So you pulled as much of the product as possible out of that section of pipe. After pressure reductions, our number one priority always is going to be people. So evacuate. That, if it's a Williams or Bluegrass facility, get our people out. If it's along the right of way, evacuate the residents, our neighbors closest to the pipeline. After that, we're going to isolate the area, deny access and entry. If you get everyone out and no one can get in, then we've accomplished our number one priority. As we go forward with that, we would establish the incident command system. It would be a unified command system with local emergency response agencies. We would work through the emergency phase of the incident. Once we got to the point where the emergency phase was over and we went into cleanup and remediation, that would be done in accordance with standard operating procedures along Bluegrass Pipeline. Bill gave me this map today, and the fact that we do have emergency management regions, that's certainly someone that we will be in contact with. There's already been some initial contact made with local emergency response agencies. We will contact these people. We won't depend on just that contact. We will work with volunteer fire, sheriff's departments, local police, and I know, I will suspect, I won't say I know, but I will suspect that in Kentucky it's a lot like most of the areas that we go through with our facility. The vast majority of the response would be done by volunteer fire, and we're very aware of that. We're acutely aware of that. We work very closely with them. We have a community giving program where we do provide monies for them to purchase equipment and those sorts of things that might be needed or necessary during a response.
Any questions from the commission? Yes, Scott?
How much of a release do you have before a bell or a whistle goes off in Tulsa? Is it 5 gallons, 50 gallons?
Again, that's going to depend on those components that I talked about, and without knowing the hydraulics or the composition that Bluegrass is going to be, it would be difficult to give you a number. I can say that on a similar pipeline system, within 24 hours, we can identify a leak of about 1.8% of the throughput, so it would depend upon the throughput.
If it was a major leak, we would see a pressure drop sooner. If it was a small little leak, it may take a little bit more time to recognize the pressure. And then bear in mind that these NGLs, when they're released, some will vaporize, and then others are still liquid temperature.
And the same information that you use as far as your leak detection, and that's why controller experience is such a big part of it. If you have a drop in pressure and associated drop in temperature on a pipeline system, then that's an indication, an immediate indication, that you have a release something. So, but the smallest would be, and that would be within about 24 hours.
I want to back up just a second. It's be a short question, short answer. But who's really on the ground with you guys inspecting this pipe installation? I mean, is US DOT actually there? And do they move into an area and work with you guys hand in hand?
During construction?
Yeah.
DOT probably will not be out during construction. I mean, they have the right to be, but during construction is you will have your own inspectors. You will have your own people and you'll have the contractor. The inspectors, both our own company inspectors and our third-party inspectors, are the key to quality control. We have to present and have for audit and review all the data about the pipe, all the construction techniques, you know, the depth of cover, all that data associated with the construction is subject to audit by PHMSA. PHMSA has the right, we're not sitting here and tell you that they will be out there. They have the right to come out anytime they want to facilitate construction.
And we've already, just might add to that, Mike, we've already, PHMSA's already been in contact with us, wanting to know our schedule, you know, from a long-term standpoint, I understand we're probably starting this year. We kind of laid that out for them about our plans, and they want to have the opportunity to inspect should they decide to come to the field.
And our experience has been recently that they won't be there for the entire, but they will show up and they'll do spot checks and they'll dig down and they see any problems, they show up more. And then if they do see problems, they also write corrective action orders. We see that in the industry like this for our pipelines, but other companies that operate disrupt pipelines.
Ron, if you could, I can't even begin to do the math on that, and I want to understand this. I want to make sure I understand this 24-hour interval at 1.8% leakage, but at a 24-inch pipeline at the pressures you guys are looking at, what's the magnitude of a leak like that before you guys can detect it? You have a rough number?
As far as, without not knowing the throughput,
I mean, is there a typical throughput? I mean, what's an example that would be?
the example that I'm talking about, and I haven't run out the barrels, and the gallons certainly sound much more significant, but the barrels, that 1.8 was on a throughput of 156,000 barrels a day.
So that was over a 24-hour, take 24 hours, so that'd be potentially 156,000, 2% of 156,000 barrels?
Yes.
Okay. Okay, and then I was just kind of curious, on your other pipelines to the country, what is an average occurrence rate? I mean, it's hard as someone totally outside the industry, I don't know, is this something that, you know, your signals go off every month, or is it every 6 months, or I mean, when do you see these levels of leakage, and when do you see the bigger ones that you can come in and contain? I mean, how often do these things happen? Totally, as someone outside the industry,
I'm not gonna make a guess, but I do know on the pipeline system that I support, the only time that has ever happened, it turned out to be a metering problem. It wasn't a leak. It was a mismeasurement, and that's why when you look at all of the components, you have to check all of those.
Did you say the only?
Yeah,
Could you get that, the only?
and it was a broader statement. I think some things that you're encountering in the state are just it's a scary concept, really. If you think it's easy to start just imagining these really scary things happening. And for you guys, you're in the industry, and this stuff rarely I mean, it's almost like, how often do planes crash? I mean, they don't crash.
I mean, unfortunately, both our industry and the airline industry is that there's a problem. You know, it makes
Captures
great
the public's
footage.
attention, I mean.
But, I mean, you know, you ask how often is, you know, we'll start with the natural gas pipelines, you've got a lot of those. Yeah, or, you know, other than maybe a very small pinhole type leak, there are very, very few ruptures of a natural gas pipeline. There are very few ruptures of an oil pipeline, and there are very few ruptures of a liquid pipeline. Those are very rare occurrences. One of the things about the way this pipeline will be designed is, right now, it's, you know, there's gonna be long stretches of that pipeline where there's not a lot of interconnections and meters and things like that, because, you know, you don't have more issues around a meter than you will along a mainline transmission pipeline. So those are all things that weigh in there. I mean, you were very much aware that people are concerned because if you've ever had a pipeline in your neighborhood, or you didn't know you had a pipeline in your neighborhood, it could be scarier, but some people who've asked questions have realized, wait a minute, there is a pipeline on the other side of that hill that they just never knew about, but didn't think about it. So it's a very fair question, but it is a rare incident where you have any type of major catastrophic incident. And, you know, on transmission pipelines, having smaller types of issues are not that frequent either. And that's the reason, you know, we're gonna have people on the ground, we're gonna be flying it. So we've got a lot of other things going on along, you know, to kind of check for some really pinhole type of leaks, which are actually very evident from the air. So those are things that we're very conscious about that.
And just to contrast it, you know, if you assume that these natural gas liquids will find their way to the marketplace, the pipeline's not installed, other methods of transporting that product will be used, such as rail. So for, you know, rail cars, the number of rail cars you would need to transport the same amount of volume, it could be up to over 17,000 rail cars a day moving up and down the line, and that'll go wherever the rail lines exist in communities and everything else. You know, we're going to great lengths to be sensitive to all these different types of environments so that we respectfully design a system that is as safe as it can possibly be.
Well, and I appreciate it. I mean, you guys have gone to great depth to explain your safeties. I'm very impressed. I guess for Kentucky, I guess one thing we're trying to evaluate here is, you know, the negative externalities that the state will be facing. I mean, obviously, you guys have an economic benefit to doing the pipeline, and we obviously have to weigh, you know, what are the negative possible extreme externalities versus the positive externalities you guys have outlined so clearly in great depth. I think maybe that is where a lot of people in the state and each community is, they're concerned because it's just such a complex topic, and you guys have done an amazing job in the last 3 hours to go through it. And you guys had to bring a whole room of experts to really do justice. But I guess from my point of view, and I thank you very much, you guys have done a great job tonight of letting me understand all the pieces. But maybe that's some of the reaction is around that. It's a scary concept, you know, just especially for lay people who just hear this and they go, wait, it's coming across the land. You know, my neighbor's land, it's not mine, I'm not getting compensated for it, and I have no control over what's happening here. But, you know, that's just an observation, and you guys obviously have done a lot of this, so you probably know as well.
Well, and to your point, you know, it goes back to having the statement I made about sometimes we in the industry, you know, take things for granted, or is, you know, we would have probably been better served if we had this meeting, and this type of meeting 6 months ago than having it now. You know, we've been very active in trying to do this in September, August. You know, we've readily admitted that we've had some missteps, but I think that what we're trying to do is lay out all the facts so people can hear all the facts and let people make their own decisions.
Absolutely, and I've been very appreciative of all this, you guys have done a great job.
Thank you.
That's all I have to say on that.
Yes, Mark.
Educate me, on what a leak looks like. I've heard mentioned that sometimes a leak might be vaporized, and it's colorless, odorless, so, you know, you can't see it, smell it, whatever, or sometimes it might be liquid. If someone's walking across the property and the pipeline's leaking, what do they see? And if it is vaporized, it's hard for me to imagine how a plane flying over can see it. How can a plane see a leak? So describe to me what a leak looks like.
Well, you guys want to take that?
Well, depending upon the composition of the product, it's gonna vaporize. I mean, it's liquid inside the pipe, kept liquid by pressure. When it hits the atmosphere, it's gonna turn into a white vapor cloud. And that would be very evident, even from an airplane. And that's not our first, line of protection or leak detection, device anyway. The aerial patrol is more for looking for the smaller leaks, and also third-party encroachment, people who may or may not have called one call. We make notifications on that, but what the aerial patrol is looking for would be dead vegetation above the pipe. That would be a pinhole leak. There might be a frost on the ground. That's what the aerial patrol would see. If there's a release and it's more than a pinhole release, you're gonna see a white vapor cloud. You're also gonna hear a roaring sound. If there's a release, you'll see it, and probably hear it. Depending again upon the composition of the product, you may have some liquids puddling there. When you look at the composition of natural gas liquids, the lighter ends are the ethane and propane. The heavier ends are the butanes and pentanes. The butanes are going to volatilize. The pentanes and C6 pluses will eventually volatilize, but they will probably be a puddle of liquid there for a while. The nature of the product is that it's volatile. It's going to volatilize, even the liquid part. It's not like you're going to have a release and you're going to have a liquid running into a ditch like water or like oil or like gasoline. It's eventually going to volatilize. They're all naturally occurring in nature. It's not a processed chemical. It's something that, given time, nature can deal with. There are bacteria and bugs that eat it. That's not what we're going to do with it, but it is a naturally occurring material. But if it's a release, you'll see it and hear it.
Okay. Any other questions from the commission? Pardon me. Again, I want to thank the public this evening for the time. I mean that sincerely. And obviously you guys flying from all over the country to come here tonight, I really do appreciate that also. Tonight, if I may, there's been several cards like these that have made their way up here. I'm going to be giving those to Arnita and Janet, and they're going to compile those, and we're going to pass those along, okay? And the results, answers, if you will, those kinds of things we're going to put on the webpage. So those of you, if you submitted questions, or even if you didn't, you kind of want to know, what those were, you'll be able to access those online, okay? Did I miss anything, Arnita? Go ahead.
One thing I wanted to bring to everyone's attention is that, the EQC has an annual Earth Day every year, and it is time for applications for those who have done something very special, or you think they've done something very special. And please make application for those who have done those things special, so that EQC can recognize them at the annual Earth Day. We thought we would drill this in because the deadline is coming up, I think, at the end of January.
March 3rd.
March 3rd. I made it January. She says March 3rd. So it'll be March 3rd. So please make sure, I'm sure that you know of many people who've done wonderful things. And I know we always talk about bad things, but we want good things for this one. So if you know of someone who has done that, please make application. PowerPoint, can we get a copy? Can you email your PowerPoint presentation to us? I appreciate that. And all of that will go up on the website. I think that's all I have. Did I miss something?
Well, let me just make one conclusory statement on behalf of the project. Ms. Gadsden and commissioners, we understand the concerns. You know, we've heard them, we're reading about it. That was the purpose of getting these people in here, and let's talk nuts and bolts, you know, and get it right on the table. We appreciate what you have to do on behalf of the Commonwealth. We understand that, and you're doing it. And we hope that it's been informative to you and hopefully the public, and give you further assurance that this project and the Commonwealth, the Kentucky portion of this interstate project is going to be well done and state of the art. You can be assured of that. And you'll be hearing more about it as it goes forward. The Cabinet Emergency Protection folks will be hearing it as the project evolves. It's going into the next phases now. And again, we appreciate the opportunity to be here.
And for myself, I just want to say I appreciate everyone. For myself, it has answered some of the questions that I had for myself. And I appreciate the effort. I know there's a lot of effort went into this type of a presentation. And I just want to thank you guys for coming in tonight and meeting with all of us in the public. Because those of us here in the Commonwealth, we love our Commonwealth, and we appreciate your time.
Do we want to, make notice here in the meeting that if we need an information educational session or a discussion, teleconference, we will do it?
Yes.
Will the audio and video be made available to you, put on the website?
Yes, I've been recording audio for this, and I will make it available.
Are we adjourned?
Do I have a motion? Okay.
Second.
All right. Everyone have a very safe trip home tonight. Be careful. Thank you all so much for your time.